Okay, hello everyone. So our next topic is sharing of charge by conductors. So in this lecture we'll discuss like if there are two conductors which have charges and if I brought them in contact with each other, then what will be the final charge on each of them? What will be the energy loss and how to calculate all the values? Okay, so moving forward. First we'll discuss some basics. Suppose we have two bodies, body 1 and body 2. And suppose temperature of body 1 is T1 and temperature of body 2 is T2. And suppose T1 is greater than T2. So if they are in contact with each other, then after some time they both will have same temperature. Suppose that same temperature is T3. So in this process, uh, look at this. There is transfer of heat. So there is transfer of heat energy from either this body to this body so that temperature becomes same. So what is actually happening? There is one quantity which is getting transferred and there is another quantity which is getting equalized. So you have to remember this concept. So the quantity which is getting transferred is heat energy and the quantity which is getting equalized is temperature. Similarly, suppose we have two containers. In one container, the height of fluid is H1 and in another container, the height of fluid is H2. Suppose density of both the fluid is same. So if I brought them in contact with each other, see with the help of a tube, then what will happen finally? If you think, finally the height will become same. So what will happen? Finally the height will become same. So transfer of fluid. So which quantity is getting transferred? Fluid. Till height becomes equal. So one quantity gets transferred and another quantity becomes equalized. Similarly, for the case of conductors, suppose we have two conductors, conductor C1 whose capacitance is C1 and conductor C2 whose capacitance is C2. Suppose C1 has charge of Q1 coulomb and C2 has charge of Q2 coulomb. So if I brought them in contact with each other, then finally suppose the final charge on C1 is Q1 dash and final charge on C2 is Q2 dash. So remember, now there is flow of charges. Now transfer of charge till potential becomes equal. So remember this thing. If you brought in contact two or more than two conductors, then finally which quantity will be same on all the conductors? That is potential, not charge. Charge can be different, but potential after they are brought in contact with each other will be same on all the conductors. So in sharing of charges, remember one thing, there is flow of charges till potential becomes equal. So now we'll discuss few properties. Suppose initially charge on Q1, charge on C1 capacitor is Q1 and charge on C2 capacitor is Q2. So V1 will be Q1 by C1, V2 will be Q2 by C2. Suppose initially only potential is equal. Suppose initial potential of V of capacitor 1 and initial potential of capacitor 2 is same. That is V1 equal to V2. Then there will be no transfer of charge. Charge will only get transferred when there is difference in potential. So the first step while solving questions of sharing is to check whether they are at same potential or not. If they are already at same potential, then there will be no flow of charges. Charges will only flow if there is potential difference between two conductors or two capacitors. So suppose V1 is not equal to V2, then there will be transfer of charge. Always remember the property of charges, that is conservation of charge. So initially the total charge was Q1 plus Q2 and finally the total charge is Q1 dash plus Q2 dash. So total initial charge will be equal to total final charge. See, there are no incoming electrons or outgoing electrons. So neither charge can increase nor charge can decrease. So total charge will remain same. That is Q1 plus Q2 equal to Q1 dash plus Q2 dash. Now charges will get transferred till potential becomes equal. So what is the final potential on C1? That is Q1 dash by C1. And what is the final potential on C2? That is Q2 dash by C2. So equalizing both these quantities, we have two linear equations and we have two variables, that is Q1 dash and Q2 dash. Now putting the values, you can get the answer. Remember, If charge is negative, take it to be negative. If charge is positive, take it positive. So if suppose Q2 is minus 2 coulomb, so in all the formulas you have to put value of Q2 to be minus 2 coulomb. You can't ignore the sign of charge. The polarity of charge is very important while calculating potential, while calculating sharing of charges. Now suppose we have a numerical. Suppose on first conductor C1 of capacitance 2 farad, charge is 4 coulomb, and on second capacitor of 2 farad, suppose charge is 6 coulomb. And if I brought them in contact with each other, then I want to know whether they will share charge or not. And if they will share charge, then how much charge will be there on each conductor. So the first step is to calculate potential of first conductor, that is V1 Q1 by C1. So basically 4 by 2, it will come out to be 2 volt. Similarly for second capacitor V2 Q2 by C2, so 6 by 2, it will come out to be 3 volt. Now see, there is potential difference. So basically they both will share charges. So there will be transfer of charge because potential is not equal. So we have two equations. See, suppose final charge on first capacitor is Q1 dash and final charge on second is Q2 dash. So Q1 dash plus Q2 dash equal to initial charge, and what is the total initial charge? 4 plus 6, 10 coulomb. Similarly, finally the potential will become equal. So final potential on conductor 1 will be Q1 dash by C1, that is 2, and final capacitance and final potential of second capacitor will be Q2 dash by C2, that is Q2 dash by 2. So 2 and 2 will get cancelled out, and we have two equations and two variables, so we can easily get the answer. Okay, now how to calculate energy loss when two conductors share charges. Now remember this thing, that when two conductors with different potential are brought in contact, then there is movement of charges, and due to which there is flow of current. This produces heat energy, and total heat energy produced is equal to initial energy stored minus final energy. Suppose we have two capacitors C1 and C2. Suppose initial charge is Q1 on C1 and Q2 on C2. After I have placed them in contact with each other, suppose final charge on C1 is Q1 dash and final charge on C2 is Q2 dash. So energy loss will be U initial minus U final. So what will be U initial? In initial case, the capacitor 1 will have Q1 square by 2C1 and capacitor 2 will have Q2 square by 2C2. Similarly, in final case, the capacitor 1 will have Q1 dash square by 2C1 and capacitor 2 will have Q2 square by 2C2. So putting all the values, you can calculate energy loss. And to calculate Q1 dash and Q2 dash, we have already discussed how to solve that in past slides. Okay, now from this topic there are many questions in your NCERT also. You have to solve them. There are solved numericals also, that also you have to solve. So if you have any doubt in this lecture, you can contact me on my WhatsApp number. And there's a quiz in the YouTube description below related to this slide. You have to submit that quiz, and if you have any problem, please let me know.